anyways, you'll get practice with it here. All right, real quick here, because you're probably zoning out. You're like, oh, this is too hard, man. Why am I paying so much attention to this? Real quick here, ready, set, go. Quick problem for you. Take care of it. Find the numerical value of each ratio below. Ready, set, go. Not so bad. Not so hard. Let's check it out here. Is that what you got? Yeah. Okay, so this here, this part to this part is going to be the same ratio as that part to that part. So this is going to be Tn over Nr is going to be the same thing. Tn over Nr, this is going to be part to part, so that's going to be 3 to 6. Look, it's going to be the same here, right? So let's check it out. I don't know if I'm writing this one down, but Sm to Mr equals Tn to Nr. Okay, what do we know about Sm to Mr? Well, we know that this is in a 3 to 6 ratio. Okay, and so that means this is going to equal 3 to 6, which is 1/2. We simplify it down. Okay, Tn over Nr, so this is now part to, wait, Tr, so Tr is the whole, okay, this whole thing here, okay? We would need to get the whole thing here, okay? 6 plus 3, what's that? That's 9, okay? That's 9 right here. So we can maybe think about this way. If this were x, I think about it this way too. If this is x, this is actually also 2x. This would be 3x, right, through angle addition postulate. So you can think about it that way here too. But anywho, Tr over Nr, well, this is me a 3 to 2 ratio. Okay, 3 to 2 ratio, okay? What would have been an easier way to figure that one out? That's maybe a little less confusing we have here. Tr over Nr, so whole to top part, equals whole, which is 9, okay? It equals Sr over whole left, which is 6, 9 over 6. Which equals 3 over 2, okay? Man, numbers. I think is the best I can explain it here, okay? So now we got to do Rn over Rt. So whole right over, top right over whole right is going to be the same as top left. 6 over whole left, okay, which is 9. 6 to 9 is in a 2 to 3 ratio. These are both divisible by 3. We get 2 over 3, okay? And that's sort of an example what you're gonna have to do with this one here. It all connects, right? It all connects here. So you're gonna have to pick it up. I mean, don't memorize all the connections here, but part to part equals part to part. And then therefore part to whole equals part to whole, okay? Whole to part equals whole to part. And as long as you kind of have that going on, part to part equals part to part as well. Part to whole equals part to whole, okay? Or part to whole, does that work? And part to whole, I'm not sure. No, it doesn't work. Let's keep going on here. All right, a couple more problems. We'll get some more problems and then you guys get into it. There we go. Ready, set, go. That one. Did I even put the problem up? Yeah, here's the problem here. All right, no problem. Pause the video. Give this one a shot. We'll check over it in a minute or two. Ready, set, go. Ready to go over this one? We're going to go over this one. Let's do number 19 first. Oh! Got it out of the way. The answers are right there. All right, AR. Come on, here we go. My mouse. All right, so AR equals 12. RT, well, we got AT is 20. So that's segment addition postulate. This is going to be 18. Ooh, you're putting the answers here. Okay, check it out here. That's going to be 8. Okay? Hopefully you got the rest of these answers here. I'll maybe go through it. AN is 18. NP is 12. Okay, so the AP is 30. So one thing I want to point out here, AT is 20. You want to get corresponding parts. They're going to be in the same ratio, right? So this is 20 right here. AP is 30. So this is going to be in a 2 to 3 ratio. Whole to whole equals part to part or part to part. Okay, so what you could do here is to get AN equaling 18, this here is 20, this here is in 30, so this is in a 2 to 3 ratio. We could take, we know that this is 12, okay, 12, so we could set it up here as 2 over 3 equals 12 over AN, right? 12 over X's here. And this is here in a 2 to 3 ratio. Okay, I don't want to do the workout. Maybe we'll do the workout for the next one. But if this is 18, that's got to be 12. And look at here. This is an A2 to 3 ratio, part to part. It all connects with the segment emission postulate and also just the proportions. They just work. Pretty cool. Okay, and then here we got TP. So remember I said during last class when I'm going over problems like this is actually the easiest part is figuring RN over TP, but it was always the hardest for me, okay? And here's sort of to remind you that you need to, in order to get this one here, RN to TP, this one here is just a side of the smaller triangle to a side of the larger triangle. So you need to go AR to AT, right? AR is a side of the left triangle. AT is, of the smaller triangle. AT is the left side of the larger triangle. So if you do AR over AT, okay, AR is 12, AT is 20. That would be, they're both divisible by 4. That would be a 3 to 5 ratio, okay? RN is 15, so 15 over X, okay? In solve for you get 25, right? Because this is an a 3 to 5 ratio as well, okay? Let's maybe do the other ones here. We got the answers in, so I'm going to show them where the rest of them came from, okay? This is 33. How would I do this one here? So let me maybe mark it up, and we can do this one together in case you're struggling with something like this here. We got this here. This is 33, okay? AN is right on a test here. Like in a test, I would just be copying this all down. It's almost like fill in the blank. What makes sense in these places here? So fortunately, when you're in the book, you have to copy your own diagrams and stuff like that. It's hard to actually write it down here. So AN is 24, and NP is, and obviously this isn't drawn to scale, NP is 20. And this is just a generic tattooable diagram for you. So that's 20. And then TP is 50. Okay, that's 50 here. All right, we got to tackle this problem here. First of all, I'd start filling this in, like what AR is. Yeah, sure, I would do that. This is 33 right here. So I would also figure out what the whole is here. Segment addition postulate, that's going to be the easy thing, right? 24 plus 20 is 44, okay? Those add together, right? This 18 plus 12, that equals 30, okay? So that's 4. That's the easy part here. So now this is 44, okay? Go down, that's 44, right? It's going to go dark over here, but that should be 44 that way. So now I notice here, this is an a 3 to 4 ratio. These are both divisible by 11. 33 over 44, that's divide by 11 over 11, you get 3 to 4 ratio, okay? But anyways, I can do this now. So AR might be the next one I want to get here. The question is, what's this going to be? Well, this one, I have various ways I can do this one. I could do this here. I can leave this as my X, okay? Or maybe I'll just do this as AR. Part to part, right? Top part of the left side over top part of the right side here, which is 24, going to equal whole of the left side over a whole of the right side. So that's going to be in a 3 to 4 ratio. And I just left it as 33 over 44, right? Just prove to you that this is going to work out here, okay? Cross multiply, you get 44 AR equal to, and here, I would have been nicer if I just simplified my fraction to 3 over 4, wouldn't it? I get 44 AR, and then I'm going to get 33 times by 24. Okay, that's 792. And I'm going to divide by 44, 18. Okay, there we go. And it's 18 right there. Okay, we're good to go. So anyways, AR equals 18. Saw all the work here. All right, that's 18. Then segment addition postulate. Check it out here. 18 plus RT equals 33. Well, how do we get to 33? This has got to be 15. Okay, but also, too, this is going to be in that 3 to 4 ratio. Look at that 3 to 4 ratio. It all connects. It's all good to go. Oh, man. Brain is frying right now. Man, math makes my brain hurt in a good way. Good for your brain growth. It's fantastic for your brain growth. So here, 15 to 20 is in a 3 to 4 ratio. Finally, RN. Looks like I didn't put the I put it right there. That's the hard one to get. Okay, RN is this one here. Okay, this is X right here. So check it out. This is always the hard one for me. I remember doing this the first few times through. This is a similar triangle on top here, okay? That to this larger triangle, okay? So here is not really, you can't really use the basic proportionality theorem on this one because basic proportionality theorem is talking about how AT and AP were divided proportionally. This is when we need to go back down to the definition of similarity, okay? Definition of similarity would tell us this triangle is similar to the large triangle here. So that means that RN and TP correspond to one another just as, right? This is small to large. Just as small here, 18 goes to large, which is 33, okay? Can I reduce that fraction at all? Well, I can divide both by 3, so I can get this as 6 over 11, but that's as best as I can do. So 6 to 11 would be the scale factor for this triangle to the large triangle right here, okay? Cross multiply, I guess TP, I already have TP. TP is 50. Okay, cross multiply here. 6 times 50 is 300. Okay, and 11 times by Rn would be on the other side. If I cross multiply 11 times by Rn. Divide both sides by 11. Oh man, it gets messy. Okay, Rn equals 300 over 11. And that's going to simplify to 27 3/11ths here. I don't know how to really simplify that in my head. I guess 11 goes into 327 times. Yeah, that makes sense. And we have 3/11ths left over. Okay. Anyways, 300 over 11, you don't have to change it to mixed fraction like that. You leave it in proper fraction, all good to go. These should be the same thing. All right, folks. Looks like we're all done. Yeah, good times. All right, basic proportionality theorem. What is it? Okay, I got a triangle, 2 sides of a triangle, parallel lines going through. It's going to divide those sides proportionally, and you can set up a whole bunch of crazy proportions, okay? Only one lesson left in chapter 5. And I know you're like, I'm done with this. When are we getting to Pythagorean theorem? Next chapter, we'll get to that. When are we getting to trigonometry? Next chapter, we're getting to that. So keep fighting the good fight. Second to last lesson. We got one more lesson after this. It'll be, I just promise you, I think it won't be too bad. It might be bad. But Monday is your last lesson. That's going to have to do with the triangle angle bisector theorem and more to do with proportions. Proportions galore in this here. Thank you for watching, guys. Email me if you have any questions. What you're looking at here isn't your homework. This is what I would normally assign. Hey, we all have our fun in class. And just like, go, just do this. Just go do it. Do it. It's not too bad. You do have your exit ticket today. Okay, exit ticket today. And then we'll have a problem set maybe similar to this for over the weekend. Okay? Email if you have any questions. Take care.